Okay, we're going to continue our work with polynomials, and we're going to talk about adding and subtracting polynomials. So, and you've actually done some of this before. To add polynomials, there's two things. First, find the like terms. Remember, terms is another word for a monomial. So we're looking for the like pieces in a polynomial that go together. They have to have the exact same variable part. So 3x, which is a term, and 7x squared are not like terms. Not only do they have to have the same variable, but they have to have the same power. Also, 4xy would not be a like term. Even though they all have x's, the first term is just a single x, the second term is an x squared, and the third is an xy. Now, if I put some additional terms in here, 3x squared, negative 2xy, and 6x, now I can find some pairs of like terms. 3x is a like term with 6x. 7x squared is a like term with 3x squared. And 4xy is a like term with negative 2xy. So once I find the like terms, if I want to add them, for example, if I want to add 3x plus 6x, I would add the coefficients, 6 plus 3 is 9, and keep the variable the same. Okay, we do not do anything when we add different x's. So if you have 3 apples and you add 6 apples to it, you still have apples. The variable doesn't change. All that changes is the number. So let's do one more. Let's take our 7x squared plus our 3x squared, and that would give us 10x squared. And do the xy's for me on your own. 4xy plus a negative 2xy would equal 2xy. Okay, so pretty simple. All right, let's take a look at a polynomial now. So for example, let's look at 3, I'm going to put this in parentheses, 3x squared minus 3x squared minus 4x plus 8. And I want to add this to another polynomial, 2x minus 7x squared minus 5. All right, so the first thing I have to do is look for my like terms. And remember, addition is commutative, so I can move things around. So I have 3x squared and a negative 7x squared. So 3x squared plus a negative 7x squared. Now, since that plus a negative is the same as subtract, I could also write this, I'm having some real problems with the pen today, as 3x squared minus 7x squared. Whichever one is more comfortable for you is fine. All right, let's look at some x terms. I've got a negative 4x plus a 2x. And then I have some constants. A positive 8 minus a 5. So let's combine these. And again, if you want these negatives to be written as plus a negative, you can do that. I think it's easier just to write minus. Okay, so 3x squared plus a negative 7x squared or minus 7x squared is negative 4x squared. Combining these two, a negative 4 plus a 2 is a negative 2x. And combining these two, a positive 8 and a negative 5 is a plus 3. Okay, let's try another one. And I'm going to let you try this on your own first. So 7x squared y plus 4x minus 3x squared. And we're going to add that polynomial to 6x squared y minus 2x squared. So pause the video, try this on your own, and come back. Okay, gathering like terms, 7x squared y plus 6x squared y. The 4x, there is no like term to go with it, so I'm just going to keep it as itself, nothing to add to it. And then my negative 3x squared minus another 2x squared. So again, like terms, 7 plus 6 is 13, x squared y. Again, the 4x. And negative 3 minus 2 is negative 5x squared. So I hope that's what you got. All right, subtract polynomials. To subtract anything, we add the additive inverse or opposite by changing all the signs in the original polynomial. We'll talk about that in a second. So if any time we subtract 7 minus 3, that's 7 plus a negative 3. We keep the first number, we change the symbol from negative to positive, and we flip the number afterwards. So I know you guys like to call that keep, change, flip. All right, let's try one. So 3n squared. Now, let me see if writing down here is easier. For some reason, sometimes this pen just doesn't like to work. Can't get anything to work today. Let's try this again. Nope. Pen. Okay. 3n squared plus 13n cubed plus 5n, that polynomial, minus 7n plus 4n cubed. So I'm going to keep the first one. I'm going to change this to addition, and I'm going to change the signs that follow. Negative 7n minus 4n cubed. So now gathering my like terms, I'm going to do the highest power first. I'm going to start with the n cubes. So I have 13n cubed minus 4n cubed. Whoops, we've got to keep going. Then I've got some n squareds. So I have a positive, there's no sign in front of this, so I know it's not subtraction. A positive 3n squared, no n squareds over here. Then I have a positive 5n plus a negative 7n, which would be the same as subtracting. So 13 minus 4, 9n cubed, plus 3 by itself, 3n squared, and then the 5n, the minus the 7n, is negative 2n. Okay, so there's one other thing we can look at here. We can arrange these in a horizontal or vertical alignment. We have been doing everything horizontally. So when we first did this problem, our addition problem, 3x squared minus 4x plus 8 plus 2x minus 7x squared minus 5, we had things lined up horizontally, and we just worked from here, left to right. 3x squared minus 7x squared, negative 4x plus 2x, and 8 minus 5. We can also line them up vertically. So if I copy my first polynomial, and then underneath I copy the second polynomial like you would a good old-fashioned addition problem. And I've got to put the terms in the same order. So I'm going to put the negative 7x squared first. Then I'm going to put the 2x under the 4x and the negative 5 under the constant. And then I'm going to add going down. 3 plus a negative 7 is negative 4. Negative 4 plus 2 is negative 2. 8 minus 5 is positive 3. So we get the same answer, different way of setting it up. Now in your book it's going to ask you to do some problems a whole bunch of problems, and it doesn't tell you which way you have to use. So you may use whichever one is most comfortable for you. I'd like you to give a try to both of them at some point. Let's look at another one of our problems that we had done before, our subtraction problem with a vertical alignment. So the problem was 3n squared plus 13n cubed plus 5n minus 7n plus 4n cubed. And again, I'm going to put the terms in order from largest power to smallest power. So I've just rearranged my first polynomial a little bit. And then I'm going to be subtracting, and again, I've got to put these terms under their appropriate spots. So this is a positive inside the parentheses, so that's a plus 7n, and we have a 4n cubed out here. Again, for subtraction, I'm going to change this to addition and change the signs of everything in my terms. So 13n squared minus 13n cubed minus 4n cubed is 9n cubed. There's no n squareds to add to this, so it still is 3n squared. And then I've got a positive 5 and a negative 7, negative 2n. So that's the vertical method for our subtraction problem. Okay, we're going to look at a quick word problem, and we're going to talk about the number of teachers in 1995. So the total number of teachers in the United States could be modeled by this equation, and I want to look at what this equation means. N represents the number of years since 1985. So remember, this is a linear equation. If I were to graph this, I would start at my y-intercept of 2216. And I don't think this was in the United States. Don't know, folks. It does say in the United States. Doesn't seem like enough to me, but that's okay. In thousands. So this is 2,216,000. That sounds better. Anyway, we start at 2,216, and this is my slope. So every year, year 1, year 2, year 3, we go up by 44. So each year, that's my rate of change, increase. Starting value is here. The secondary teachers, which is another way of saying high school, middle school, high school teachers, can be modeled by 11n plus 942. That means in 1995 there were 942,000 secondary teachers, and each year that number increased by 11,000. So this is a way to model the growth of teachers. Now my question is, how many elementary teachers would there be? So if the total number of teachers is modeled by this and the secondary teachers are modeled by this, the elementary teachers would be the difference of the total minus the secondary. So we're going to take 44n plus 2216, and we're going to subtract 11n plus 942. We're going to get, remember, subtraction. I'm going to change that to addition and change both these signs. So 33n plus 1,274,000. And that's my elementary teachers. So using this model now, I could, for example, find out how many teachers there were in 1995. How would I do that? If n represents the number of years since 1985, 10 years later, the elementary teachers would be 33 times 10, the number of years that have passed. We've added 33 each year, plus the original 1,274. So that's 3,300 plus 1,274. Let's see, I didn't do this ahead of time. So that's 4, 10, 6, 1,604 for elementary teachers. Okay? So again, given two models, we should be able to subtract the difference. It's important that you understand what this means. that when you're told that n represents the number of years since 1985, you know that this is your slope going up 44 each year, and that this is your initial starting point. How many teachers were there when we started in 1985? Okay, and that's it.